Before a locomotive could move, someone had to oil every part of it. There is a quiet place, not often seen, where the day begins and ends in a steady and unhurried rhythm. It is a place of warm light and deep shadow, where the soft glow of a lamp rests upon worn wood, polished metal, and pages of careful instruction. This was the railwayman's work, and it was done diligently and without haste. Here the world moves more slowly, not because it must, but because there is no need for haste. Every task has its time, and every movement its purpose. If you are listening now, you may already be somewhere quiet yourself. Perhaps it is late in the evening or the early hours of the morning. Wherever you are welcome here. You do not need to follow closely. You do not need to remember anything that is said. You may simply listen or allow the words to drift past as gently as the steady breath of steam in the distance. Tonight, we spend a little time in the company of a railwayman, seated at his workbench beneath the soft light of a lamp, reading from a book of quiet importance. Its pages speak of simple things, of oil and motion, of care and attention, and of the unseen work that allows great machines to move with ease. These are not hurried lessons nor complicated ones. They are the kind of knowledge that settles slowly, like warmth into metal, or like rest into a quiet mind. As we begin, you may notice the stillness of the shed around us, the faint scent of oil and warm iron, the distant shape of a locomotive resting in shadow, and the gentle presence of tools laid out with care. Nothing here demands your attention, nothing requires effort. And so, as the railwayman turns the first page and the quiet work begins, you may simply settle in and allow yourself to rest. The quiet art of lubricating a steam locomotive. Tonight we're taking a gentle journey into the quiet, precise world of steam locomotives, where every bearing, every drop of oil, and every valve moves with purpose. Sit back, settle in, and let the rhythm of pistons, rollers, and softly dripping oil carry your mind toward rest. Wherever you are in the world this evening, this quiet voyage is just for you. Before we begin, I'd love to know, where in the world are you listening tonight? If you can, please take a moment to leave a comment below. Is it late evening, past midnight, or the quiet hours of early morning? Wherever you are, allow the soft hum of machinery, the whisper of oil, and the careful dance of moving parts to guide you gently into rest. Part 1. Introduction to lubrication and bearings. Let us begin quietly, settling into a gentle rhythm, allowing the mind to drift as we explore the subtle and essential art of locomotive lubrication. Steam locomotives are complex machines, their vast iron and steel structures moving in perfect synchrony, if properly maintained. At the heart of this motion lies a small but critical companion: lubrication. Imagine the pistons driving the wheels, the rods sliding through the guides, the axle boxes turning within their housings. Without lubrication, friction would quickly turn this elegant motion into grinding metal heat and wear. Oil, applied in careful measures, forms a protective layer, ensuring that every moving part glides smoothly, quietly, efficiently. Bearings, the small but essential points where metal meets metal, require this protective layer above all. Without the thin film of oil, the rolling surfaces would scrape and seize. There are different types of bearings used in locomotives: plain bearings, roller bearings, and the more specialized tapered roller bearings for handling both radial and thrust loads. Each relies on lubrication to perform its work without excessive heat or wear. The big end bearing and connecting rods. Consider the connecting rod, the long arm linking the piston to the wheel. At its larger end, called the big end, it houses a bearing that must endure heavy loads with every stroke of the piston. The oil applied to the big end must reach every surface, forming a consistent film that prevents metal-on-metal contact. This is often achieved through a mechanical lubricator or, in some cases, a siphon system. The engineer must carefully examine the needles and the nozzles, ensuring that oil flows in measured drops. Too little oil and friction increases. Too much and oil may be wasted or spill onto parts where it is not needed. Each of these elements, the needle guide, the felt pad, the siphon plug, and the oiling washer, work together to maintain a precise, gentle, and continuous lubrication. Fountain-type axle box lubricators. One of the most fascinating systems is the fountain-type axle box lubricator. This system, when properly operated, delivers oil from a reservoir to the moving bearings in drops regulated by a needle. To fill the reservoir, the handle is set to off, the plug removed, and clean oil poured in carefully. Once replaced and secured, the system is ready for operation. The handle, when set to on, allows the oil to flow in a controlled manner. The rising and falling level of oil in the feed chamber, aided by air tubes and the simple mechanics of pressure and gravity, ensures a steady, continuous flow. The elegance of this system lies in its simplicity. It does not require complex electronics or sensors, only careful observation and proper handling by the engineer. Checking needles and flow. Before operation, needles must be examined. Any foreign matter accumulated around the needle or nozzle may block the flow of oil. Only when these components are clean can the handle be set to on, and the system will function as intended. Interestingly, the handle itself does not regulate oil flow. Flow is determined by the size of the needle. If a bearing requires more lubrication, the needle can be temporarily replaced with a larger size to allow more oil to reach the moving surfaces. With these systems in place, the locomotive's heart beats smoothly, quietly, and efficiently. Part 2. Functioning and types of bearings. Now let us drift into the inner workings of the machine, exploring how oil travels and how bearings are designed to bear the immense weight and motion of the locomotive. Oil flow and air regulation. When the handle is set to on, oil rises in the feed chamber, flowing through the nozzle in measured drops. As the oil level drops, air enters through the reservoir, equalizing pressure and allowing more oil to flow. This cycle continues quietly as the locomotive moves. When the handle is set to off, oil continues to feed auxiliary chambers, maintaining lubrication even during stops. The careful interplay of air and oil ensures that bearings remain coated, reducing friction and preventing overheating. This system is simple yet effective, a masterpiece of engineering that has endured for generations. Roller bearings and cannon boxes. Roller bearings have become increasingly common in axle boxes, replacing plain bearings for many applications. These consist of a cone, a cup, rollers, and a cage. The cone rotates with the axle, while the cup remains stationary. The rollers transmit the load, while the cage ensures proper spacing and alignment. In some designs, double bearings are used, effectively doubling the rolling surfaces. The cast steel cannon box encloses two bearings in a tubular housing, providing protection from dirt, water, and debris, while handling both radial and thrust loads. These bearings are lubricated by oil, which circulates automatically as the rollers turn. The careful maintenance of oil levels, cleanliness and inspection ensures that these components function quietly and efficiently, extending the service life of the locomotive. Atomizer lubrication. In addition to mechanical lubricators, atomizer lubrication uses a steam jet to atomize oil and deliver it to the cylinders. This system requires attention to the cylinder cocks, ensuring that the steam used for atomization does not interfere with other functions. Proper use allows the oil to reach all critical surfaces, forming a protective film that reduces wear and heat. Worsted trimmings and plugs. Other forms of lubrication involve worsted trimmings. Plugs and tail trimmings made of strands of worsted allow small quantities of oil to be delivered precisely to moving or rotating parts. Pads are used for expansion blocks and side blocks. These slow, steady applications of oil maintain the machinery's efficiency throughout the day. Part 3. Brakes and safety systems. Now, as our journey continues, let us move to another vital system of the locomotive, the brakes. Though different from lubrication, the brakes rely on similar attention to detail, observation, and careful maintenance. The principle of braking. The function of a brake is to absorb the momentum of the train, converting energy into heat. On freight trains without continuous power brakes, the locomotive and guard's van provide the primary braking force. On passenger trains, continuous braking systems, including the automatic vacuum brake and the Westinghouse air brake, are used to ensure safety and compliance with regulations. Vacuum brakes and steam brakes. The automatic vacuum brake uses atmospheric pressure, regulated by vacuum ejectors. Air admitted to the train pipe destroys the vacuum, allowing the brake pistons to move and apply the brakes. The steam brake works in conjunction with the vacuum system on many locomotives. As the vacuum in the train pipe changes, steam is admitted to or released from the brake cylinders, ensuring smooth and graduated braking. Driver's brake valve and control. The driver's brake application valve allows precise control of the braking force. Moving the handle on admits air into the train pipe, reducing vacuum and causing the steam brake cylinder to engage. Releasing the handle allows the vacuum to restore, the pistons return, and the brakes disengage. Manual operation is possible when running light engines, allowing full control of steam braking through a lever and quadrant mechanism. The compression spring ensures that the degree of brake application is proportional to lever movement. Observation and maintenance. As with lubrication, careful observation is essential. Engineers monitor vacuum levels, listen for irregular sounds, and check that valves function correctly. Attention to these details ensures both the safety of the train and the smooth operation of its machinery. Regular inspection of brake cylinders, pipes and valves complements the meticulous work done on bearings and lubrication. Together, these routines form the quiet discipline of railway maintenance, ensuring that every journey is safe and reliable. Part 4. Observation, maintenance and the evening depot. Finally, we turn to the concluding routines of the day as the locomotives return to the shed and the railway staff perform their evening inspections. The yard has grown still. Lamps cast gentle light on rows of engines resting peacefully. The day's work is complete. The engines cool, ticking faintly as the metal contracts. Railwaymen begin their evening routines. Lubricators are checked and refilled. Oil levels are observed, pipes are cleared, and any worn components noted for repair. Cleanliness is essential. Even a small contamination of oil can cause serious damage. Listening and feeling bearings. Engineers walk alongside the resting locomotive, feeling the temperature of the bearings and listening for subtle sounds. Warmth is normal, overheating is not. By touch and careful observation, early problems are identified and addressed. The discipline of observation extends to every moving part. A knock, a squeak, or a smell may indicate the need for attention. The quiet habits of the railwayman ensure that the locomotive remains in peak condition. Workshop maintenance. In workshops, more rigorous inspections occur. Bearings may be dismantled and examined, lubricators are cleaned and tested, valves and pipes are adjusted. Through this care, the locomotive's longevity is preserved. Reflection and closure. As the night deepens, the engines rest. Their lubricated bearings, filled oil chambers and well-maintained brakes ensure that tomorrow's journeys will begin smoothly. The quiet routines of lubrication, observation and maintenance form the unseen foundation of reliable rail travel. The lamps dim, the workshop quiets. The locomotives stand in patient readiness, awaiting the morning, each prepared to carry passengers or freight safely and efficiently. In this calm stillness, we close our study of lubrication and the careful discipline of railway engineers. A thin film of oil has kept these mighty machines in motion, a reminder that even small, quiet actions can sustain great power and enduring performance. Methods of lubrication. If we continue our quiet reading, we find that lubrication is not a single act, but a collection of gentle methods, each suited to its own small task. The railwayman does not simply apply oil at random, nor does he rely on chance to carry it where it is needed. Instead, there exists a quiet system, developed over many years, in which each moving part is cared for in its own particular way. Each method has its place, and each serves a purpose that may seem small, but is in truth essential to the smooth and steady working of the locomotive. We may begin with the simplest of all, a method that requires little more than patience and a careful hand. This is known as hand lubrication. In this method, oil is applied directly to the moving parts by means of an oil can or feeder. The railwayman moves slowly along the engine, pausing at each point where motion occurs, placing a measured drop of oil where it is required. There is something almost meditative in this process. The act is repeated many times, each movement deliberate and unhurried, each application made with quiet attention. The oil spreads across the surface, forming a thin and protective film. It is not visible in any dramatic way, yet it performs its duty faithfully, reducing friction and preventing wear. From this simple beginning, we move to a method that relies not on direct application, but on gentle absorption and steady release. This is known as pad lubrication, often using what is called worsted trimming. A soft pad made from strands of material is placed so that it rests within a small reservoir of oil. The material draws the oil upward slowly and continuously, feeding it to the surface that requires lubrication. It is a quiet and reliable method, requiring little attention once properly arranged. The oil moves not by force, but by the natural tendency of the material to carry it along its fibers. In this way, a steady supply is maintained, neither too much nor too little, but just enough to sustain the motion of the part. Closely related to this is the method known as siphon lubrication. Here, a strand or trimming extends from a small oil chamber to the point where lubrication is needed. The oil travels along this trimming, guided by gravity and absorption until it reaches the moving surface. It is a slow and gentle process, almost unnoticed, yet entirely dependable. The railwayman understands that such methods, though simple, must be kept clean and in good condition. A clogged trimming, or one that has become worn, may fail to deliver the oil as intended. And so, even these quiet components require occasional care and renewal. As we turn another page, we come to methods that are a little more intricate, though no less calm in their operation. These are the mechanical lubricators. Unlike the hand-applied methods, these devices are designed to deliver oil continuously, driven by the motion of the locomotive itself. Within a small metal casing, a series of tiny pumps operate in a steady rhythm, each one delivering a measured quantity of oil to a specific point on the engine. The motion that drives these pumps is taken from the locomotive's own moving parts, so that as the engine works, so too does the lubricator. It is a quiet partnership, the motion of the machine ensuring its own care. Each pump delivers only a small amount, but over time, these small amounts combine to provide a constant and reliable supply. There is no haste in this system, no sudden flow or excess. Everything is measured, controlled, and steady. The railwayman, before setting out, may turn a small handle to ensure that oil has begun its journey through the pipes, gently preparing the system for the work ahead. From here, we come to a method that is both subtle and ingenious, known as hydrostatic lubrication or displacement lubrication. In this system, the movement of oil is assisted by the presence of steam. As steam condenses within the lubricator, it forms water, and this water, in turn, gently displaces the oil, causing it to rise and pass into the delivery pipes. It is a quiet exchange, one substance giving way to another, ensuring that the oil is carried forward without the need for mechanical force. The oil then travels through sight glasses, where its movement may be observed as a slow and steady series of drops. Each drop marks the passage of oil into the system, a visible reminder that lubrication is taking place. There is something reassuring in this sight, a calm and steady rhythm that mirrors the motion of the engine itself. The railwayman may adjust the rate of flow, increasing or decreasing the number of drops as required, always seeking that quiet balance between too much and too little. Beyond this, there exists another method, one that is less visible, yet equally important. This is known as atomized lubrication. Here, the oil is broken into a fine mist and carried along with steam into the cylinders. It is dispersed evenly across the internal surfaces, reaching areas that would otherwise be difficult to access. This fine distribution ensures that all parts receive the protection they require, even those hidden deep within the machinery. The process is gentle, almost invisible, yet highly effective. As we continue, we find that some parts of the locomotive require a slightly different approach. For rotating components, such as connecting rods and bearings, a method involving restrictors or controlled feeds is often used. In these systems, the oil is delivered through a small opening, carefully regulated to ensure that only the correct amount reaches the moving part. The motion of the component itself assists in distributing the oil, spreading it evenly across the surfaces. There is a quiet harmony in this, the movement of the machine helping to maintain its own condition. We may also consider the use of grease, which serves in places where oil alone may not remain in position. Grease is applied under pressure, often through small fittings, ensuring that it reaches the necessary parts and remains there for a longer period. It is particularly suited to areas where movement is limited or where a thicker lubricant is required. And so we begin to see that lubrication is not a single action, but a carefully balanced system of methods, each one chosen for its suitability to a particular task. Some methods are simple and direct, while others are more complex and subtle. Yet all share the same purpose: to reduce friction, to prevent wear, and to ensure the smooth and reliable operation of the locomotive. The railwayman understands that no single method is sufficient on its own. It is the combination of all these approaches working together quietly and continuously that keeps the engine in good order. There is no single moment when lubrication is complete. It is an ongoing process, a constant presence, much like the steady ticking of a clock or the quiet breathing of a resting machine. And as we sit here, turning the pages slowly, we begin to appreciate the calm and thoughtful nature of this work. Nothing is hurried, nothing is wasted, and nothing is left to chance. Each drop of oil, each carefully arranged system contributes to the greater whole, ensuring that when the locomotive moves, it does so with ease and quiet efficiency. And so, as the railwayman continues his reading and the gentle rhythm of the shed surrounds us, we are reminded once again that even the smallest actions, carried out with care and patience, can sustain the motion of something far greater. The page turns softly and the quiet work continues. Lubrication of axle boxes. As the page turns quietly onward, our attention is drawn to a part of the locomotive that carries a great and constant burden, yet does so without drawing notice to itself. These are the axle boxes, resting beneath the weight of the engine, supporting not only the mass of the locomotive, but also the motion that passes through it. It is here, at these points of contact between axle and frame, that careful lubrication becomes especially important. For while many parts of the engine move in visible and rhythmic ways, the axle boxes perform their work more quietly, turning steadily beneath the load, their motion continuous and unbroken for mile after mile. If we consider their role, we begin to understand the importance of their care. The axle boxes may be divided into two general kinds. There are those that carry only the weight of the locomotive itself, such as those found on bogies, pony trucks and tenders. These are known as dead load bearings. Then there are those that carry not only weight, but also the force of motion generated by the pistons and transmitted through the wheels. These are the driving and coupled axle boxes, often referred to as power bearings. It is this second type that bears the greater responsibility, for it must support both weight and effort, quietly absorbing the forces that pass through the locomotive as it moves along the rails. In both cases, lubrication must be steady, reliable, and sufficient, for without it, friction would build, heat would rise, and the smooth turning of the axle would soon be lost. In many axle boxes, lubrication is provided through what is known as an underkeep. Within this space, a reservoir of oil is maintained, and from it, a pad or trimming draws the oil upward to the bearing surface. This is a continuation of the gentle methods we have already considered, where oil is supplied slowly and consistently rather than in sudden or excessive amounts. The railwayman, in preparing the locomotive, will always ensure that the oil level within the underkeep is sufficient. This is not a task to be overlooked, for even a small deficiency, unnoticed at the start, may grow into a greater problem over time. The pad itself must also be in good condition, clean and capable of drawing the oil effectively. If it becomes worn or obstructed, the flow of oil may be reduced and the bearing may begin to run dry. And so even these simple components demand quiet attention. In addition to underfeed lubrication, there are other arrangements by which oil is introduced to the bearing surface. In some cases, grooves are cut into the bearing itself, allowing oil to spread more evenly across the area of contact. These grooves may be straight, oval, or arranged at an angle, each design intended to guide the oil and ensure that it reaches all necessary surfaces. In other arrangements, small holes are provided through which oil may be delivered directly to the bearing. These methods, though varied in form, share a common purpose to ensure that the oil is distributed evenly and remains present where it is most needed. As the axle turns, the motion itself assists in spreading the oil, forming a thin and continuous film between the surfaces. This film, though delicate, is remarkably effective. It prevents direct contact between metal surfaces, reducing friction and protecting the bearing from wear. When this film is maintained, the axle box runs smoothly and quietly, its motion almost effortless despite the weight it carries. However, if the supply of oil is insufficient or if the distribution is uneven, the situation changes. Friction begins to increase, and with it, heat. This heat may build gradually, at first unnoticed, but over time it may become significant, leading to what is known as a hot axle box. Such a condition is never taken lightly, for it may lead to damage if not addressed. The railwayman, experienced and attentive, may detect the early signs of this through touch, through observation, or through the subtle changes in the behavior of the locomotive. And when such signs appear, action is taken calmly and without delay. Additional lubrication may be applied or adjustments made, always with the aim of restoring the quiet and steady motion of the bearing. In more modern practice, some locomotives are fitted with roller bearings in place of the traditional plain bearings. These represent a different approach, one in which the load is carried not by sliding surfaces, but by rolling elements. Within these bearings are carefully arranged rollers enclosed between inner and outer races and held in position by a cage. As the axle turns, these rollers move smoothly along their paths, reducing friction to a very low level. The difference is subtle in appearance but significant in effect. Where a plain bearing relies on a film of oil to prevent contact, a roller bearing reduces contact by allowing motion to occur through rolling rather than sliding. Even so, lubrication remains essential. Oil is still required to protect the surfaces, to reduce wear, and to ensure the continued smooth operation of the bearing. The oil is often contained within the axle box itself, circulating gently as the rollers move, and its level must be checked from time to time. The railwayman remains mindful that even with improved designs, the principles of care do not change. Cleanliness, correct oil levels, and regular inspection remain as important as ever. For no matter how refined the mechanism, it still depends upon these quiet and consistent attentions. There is also the matter of keeping the axle box free from dirt and moisture. Foreign material, if allowed to enter, may interfere with the smooth movement of the bearing or contaminate the oil, reducing its effectiveness. And so, seals and covers are maintained and inspections carried out, ensuring that the interior remains clean and protected. As we reflect upon all of this, we begin to see that the lubrication of axle boxes is not a single act, but an ongoing responsibility. It is a quiet vigilance maintained over time, ensuring that the unseen work beneath the locomotive continues without interruption. The axle boxes do not call attention to themselves, nor do they demand recognition. They simply perform their duty, turning steadily beneath the load, supported by the thin and faithful film of oil that separates motion from resistance. And so, as the railwayman continues his reading and the calm of the shed remains around us, we are reminded once again of the importance of these small and careful acts. For it is here, in these quiet points of contact, that the smooth and reliable motion of the entire locomotive is sustained. The page turns gently and the steady rhythm of the work carries on. Mechanical lubricators. As the quiet reading continues and the steady rhythm of the shed surrounds us, Our attention is drawn to a device of quiet precision, one that works faithfully in the background, almost unnoticed, yet essential to the life of the locomotive. This is the mechanical lubricator. Unlike the simpler methods we have already considered, where oil is applied by hand or drawn gently by trimming, the mechanical lubricator performs its task continuously, guided not by direct human action, but by the motion of the locomotive itself. It is, in a sense, a companion to the engine, working alongside it, responding to its movements, and quietly ensuring that each part receives the care it requires. Housed within a sturdy metal casing, often mounted securely upon the frame, the lubricator contains within it a number of small and carefully arranged components. At first glance, it may appear unremarkable, yet within this compact space lies a system of measured movement and controlled delivery, designed to operate with calm reliability over long periods of time. Inside, there are pumps, small and precise, each one dedicated to supplying oil to a particular part of the locomotive. These pumps do not act randomly, nor do they deliver oil in uncertain amounts. Instead, they move with a steady and deliberate rhythm, each stroke measured, each delivery consistent. The motion that drives them is not separate from the locomotive, but taken directly from it. As the engine moves, as rods turn and wheels revolve, a small portion of that motion is quietly transferred to the lubricator. This movement is converted into a gentle, reciprocating action within the device, causing the pumps to rise and fall, drawing in oil and sending it onward through narrow passages and pipes. It is a quiet and continuous process, one that requires no attention once set in motion, yet provides a constant and reliable supply. Each pump is responsible for a particular point, perhaps a bearing, a valve, or a cylinder, and each delivers only what is needed, no more and no less. The oil itself is held within a reservoir contained within the lubricator body. Before a journey begins, this reservoir is carefully filled, the oil often passed through a fine mesh or strainer to ensure that it is clean and free from any particles that might interfere with its movement. Clean oil is essential, for even the smallest impurity may find its way into a passage or valve, disrupting the quiet precision of the system. The railwayman, in preparing the locomotive, will take care to ensure that the reservoir is filled to the proper level. He may pause for a moment, checking the contents, ensuring that all is in readiness before the engine is set into motion. Often, there is a small handle or wheel attached to the lubricator, allowing it to be operated by hand. With a few gentle turns, the pumps are set in motion, and oil begins its journey through the system. This simple action ensures that the pipes are filled, that the oil has reached its destinations, and that all is prepared for the work ahead. It is a quiet beginning, a moment of preparation before the greater movement of the locomotive begins. As the engine gathers life, as steam builds and the wheels begin to turn, the lubricator comes fully into operation. Driven by the motion of the locomotive, it works steadily and without interruption. Each stroke of the pump draws oil into the chamber, and with the return movement, that oil is gently forced onward, passing through small valves and into the delivery pipes. There is no haste in this movement. It is smooth, measured, and continuous, a steady pulse that mirrors the rhythm of the engine itself. Within the lubricator, small valves control the direction of flow, ensuring that the oil moves forward and does not return. These valves open and close with quiet precision, responding to the pressure within the system, allowing the oil to pass in one direction only. The design is simple in principle, yet refined in its execution, ensuring that each part of the locomotive receives its share of lubrication at the proper time. In some systems, the rate at which oil is delivered can be adjusted. This is done by means of regulating plugs or screws, which control the amount of oil passing through each pump. By turning these carefully, the railwayman may increase or decrease the supply, matching it to the needs of the locomotive. It is not a matter of guesswork, but of experience and understanding, acquired knowledge gained over time. Too little oil and the parts may run dry. Too much and there may be waste or even interference with proper operation. And so, the balance is found not in haste but in careful observation and steady practice. As the oil leaves the lubricator, it travels through a network of narrow pipes, each one leading to a specific destination. These pipes, though small, are essential pathways, carrying the oil to the points where it is needed most. The journey is not hurried. The oil moves steadily, guided by pressure and flow, until it reaches the moving parts of the engine. There, it spreads across the surfaces, forming the thin and protective film that allows motion to occur smoothly and without resistance. In some cases, particularly where lubrication is required within the cylinders, the oil is combined with steam. This process, known as atomization, breaks the oil into a fine mist, allowing it to be carried along with the steam and distributed evenly within the cylinder. It is a subtle and effective method, ensuring that even hidden surfaces receive the care they require. The steam itself assists in this process, carrying the oil gently into place where it settles upon the moving parts. It is a quiet cooperation between steam and oil, each playing its part in the smooth operation of the engine. The railwayman understands that even with such carefully designed systems, attention must still be given. The lubricator must be checked, its contents monitored, its operation observed. If a pipe becomes blocked or a valve fails to seat correctly, the flow of oil may be interrupted. And so from time to time, the system is inspected, not with urgency, but with calm and careful attention. The movement of oil through the pipes may be observed at certain points where small sight glasses allow the railwayman to see the flow. Here, the oil appears as a series of slow and steady drops, each one marking the passage of lubrication through the system. There is something deeply reassuring in this sight. Each drop confirms that the system is working, that the quiet care of the machine is continuing without interruption. It is a rhythm within a rhythm, a gentle and continuous movement that mirrors the steady turning of the wheels. As we reflect upon this, we begin to see that the mechanical lubricator is more than a device. It is a quiet guardian of the locomotive's motion, working steadily in the background, ensuring that each part remains protected and free to move as it should. It asks for little attention once set, yet it gives much in return, preserving the life of the machine and supporting its long and faithful service. And so, as the railwayman continues his reading and the soft light of the lamp falls across the page, we are reminded once more of the importance of these unseen systems. For it is not only the visible motion of the locomotive that matters, but the quiet processes that support it, moment by moment, mile by mile. The mechanical lubricator, with its steady and measured action, is one such process, a constant presence in the life of the engine. And in its quiet, unhurried way, it plays its part in the greater rhythm of steam and motion. The page turns softly, and the calm work continues. Hydrostatic lubricators. As we turn the page once more, the quiet reading leads us toward a method of lubrication that is both subtle and quietly ingenious. a system that relies not on moving parts or mechanical drive, but on the gentle interaction between heat, steam, and the natural behavior of liquids. This is the hydrostatic lubricator. At first, it may seem almost curious that such a device can operate without the steady motion of rods or pumps, and yet within its calm and self-contained design, it performs its duty with remarkable consistency. It is a system that does not hurry, does not force, and does not depend upon complex movement, but instead works through a quiet and continuous exchange between steam and oil. To understand its action, we must begin with its setting. The hydrostatic lubricator is usually placed where it may be connected to the steam supply of the locomotive, for it is steam that provides the gentle force required for its operation. Within the lubricator there is a chamber, carefully sealed, which contains oil. This oil does not move of its own accord, nor is it driven by mechanical action. Instead, it waits, held within the chamber, ready to be displaced in a slow and controlled manner. Above or within this chamber is a small coil or passage through which steam is allowed to pass. As the locomotive works, steam enters this coil, and in doing so, it begins to cool and condense. This condensation is a quiet and gradual process, one that occurs naturally as the steam loses heat. As the steam condenses, it becomes water, and this water begins to collect within the lubricator. Now, it is here that the quiet ingenuity of the system becomes clear. The water, forming slowly from the condensed steam, begins to occupy space within the chamber. And as it does so, it gently displaces the oil. There is no sudden movement, no forceful action, only a gradual and steady pushing of oil by the increasing presence of water. The oil, having nowhere else to go, begins to rise. It moves upward through the lubricator, guided by carefully arranged passages, until it reaches the point of delivery. From here, it passes into small pipes, carried onward toward the parts of the locomotive that require lubrication. This entire process is quiet and continuous, governed not by mechanical motion, but by the natural behavior of steam and liquid. As long as steam is present, and as long as condensation continues, the system will operate. The flow of oil is often made visible through what are known as sight feed glasses. These small windows into the system allow the railwayman to observe the passage of oil as it moves through the lubricator. Within the glass, the oil appears as a series of small drops, rising slowly through the water. Each drop marks the movement of oil toward the delivery pipes, a gentle and steady rhythm that can be watched without haste. There is something deeply calming in this sight. The slow rise of each drop, the quiet certainty of its movement, reflects the nature of the system itself, unhurried, reliable, and consistent. The railwayman may pause for a moment, watching these drops, noting their frequency and adjusting them if necessary. For even in such a gentle system, control is still required. There are small regulating valves which allow the rate of flow to be adjusted. By turning these slightly, the railwayman may increase or decrease the number of drops passing through the sight glass. It is a delicate adjustment, one that requires a steady hand and a patient eye. Too rapid a flow may lead to waste, while too slow a flow may leave parts insufficiently lubricated. And so, once again, balance is sought, not through force, but through careful observation and quiet understanding. The oil, once it leaves the lubricator, continues its journey through narrow pipes, carried along by the steam that flows within them. In many cases, the oil is atomized as it travels, broken into a fine mist, and distributed evenly within the steam passages and cylinders. This ensures that all surfaces receive a thin and even coating, protecting them from friction and wear. It is a process that is almost invisible, yet entirely effective. The hydrostatic lubricator, though simple in its principle, requires careful handling and preparation. Before use, the reservoir must be filled with clean oil. This is done slowly, allowing any air or pressure within the chamber to escape gently. The railwayman takes care not to rush this process, for even here, calm attention is essential. Once filled, the lubricator must be brought into operation in the correct sequence. Steam is admitted first, allowing time for condensation to begin. Then, water and oil controls are adjusted, and the system begins its quiet work. It is not immediate, nor is it abrupt. The flow builds gradually as the conditions within the lubricator settle into balance. And once established, it continues steadily. There are times when the locomotive may be at rest, and in such moments the behavior of the lubricator must be considered. Steam may be shut off, and the flow of oil will slow and eventually cease. But when the locomotive is brought back into motion, the process begins again, as naturally as before. The railwayman understands that patience is required. The lubricator must be allowed time to settle, to find its rhythm, and to deliver oil in its quiet and measured way. If the system is disturbed or if air enters where it should not, the flow may be affected. And so, from time to time, the components are checked, the pipes examined, and the sight glasses observed, ensuring that all remains in good order. There is also a quiet awareness of temperature. The oil within the lubricator may thicken in cold conditions, and in such cases gentle warming may be required to ensure that it flows as intended. Again, there is no haste, only a calm adjustment to the conditions at hand. As we consider all of this, we begin to see that the hydrostatic lubricator is not merely a device, but a system that reflects a deeper understanding of natural processes. It works with the properties of steam and liquid rather than against them. It does not impose motion, but allows it to arise naturally, and in doing so, it provides a steady and reliable means of lubrication, one that has served the locomotive faithfully over many years. It is quiet, self-contained, and dependable. It requires attention but not constant intervention, and it performs its work with a calm consistency that matches the steady rhythm of the engine itself. As the railwayman continues his reading, and the soft glow of the lamp remains upon the page, we are reminded once more of the quiet intelligence behind these systems. They are not complex for their own sake, nor intricate beyond necessity. They are simply well considered, thoughtfully designed, and gently effective. And so, as the slow rise of oil through the sight glass continues, and the quiet exchange between steam and liquid carries on unseen within the lubricator, the steady work of the locomotive is supported once more. The page turns softly, and the calm and unhurried rhythm of the shed continues without end. Common faults and quiet troubleshooting. As the quiet reading continues and the steady rhythm of the shed remains unchanged, the next pages turn toward a subject that, at first, might seem less peaceful, yet in practice is approached with the same calm and measured attention. These are the small faults and quiet irregularities that may arise in the working of the locomotive, and the gentle methods by which they are understood and resolved. For in the world of steam, not every imperfection announces itself loudly. Many reveal themselves slowly through subtle changes, slight variations in sound, or the faintest difference in movement. The experienced railwayman does not react with haste or alarm. Instead, he observes, he listens, he allows the machine to speak in its own quiet way. Often the first indication of a fault is not seen, but heard. A change in the rhythm of the engine, perhaps a slightly uneven beat from the exhaust, or a soft knock that was not present before. These sounds, though small, are never ignored. They are noted, considered, and placed carefully within the railwayman's understanding of the locomotive. From there, he may begin to consider what might lie behind them. A knock, for instance, may suggest looseness in a bearing or wear within a joint. It may be no more than a slight irregularity, or it may be the early sign of something that requires attention. And so, rather than rushing to act, the railwayman brings the locomotive gently to a controlled state, allowing himself the opportunity to observe more closely. The engine may be positioned carefully, perhaps with the crank in a particular orientation, so that each part may be examined in turn. The motion is then reversed slowly, the regulator opened just enough to allow movement, while the railwayman watches and listens. In this way, the source of the sound may be identified, not through guesswork, but through calm and deliberate observation. Another indication may come not from sound, but from heat. A bearing that is insufficiently lubricated will begin to warm, at first only slightly, but over time this warmth may increase. The railwayman, passing his hand gently over the surface, may feel this change. It is not a sudden heat, but a gradual rise, one that must be recognized early. If such a condition is found, the response is measured. Additional lubrication may be applied, the supply increased, and the movement observed once more. The aim is not to force a solution, but to restore balance, to return the bearing to its proper state of quiet and steady operation. In some cases, the fault may lie within the lubrication system itself. A pipe may become partially obstructed, or a trimming may fail to draw oil as it should. In such instances, the flow of oil may be reduced or interrupted entirely. The signs of this are often subtle. The sight glass may show fewer drops than expected, or none at all. The surface that should be lightly coated may appear dry. These are quiet indications, but they are clear to the attentive eye. The remedy, once again, is approached calmly. The pipe may be examined, cleared if necessary, or the trimming replaced. The system is restored and the flow of oil resumes its gentle and steady course. There are also occasions when steam and oil do not interact as expected. Within hydrostatic systems, for example, a disturbance in the balance between steam and water may affect the delivery of oil. Air may enter the system, or condensation may not occur as it should. In such cases, the flow may become irregular. The railwayman does not force the system, but instead allows it to settle. He may close and reopen the appropriate valves, allowing the internal conditions to re-establish themselves. Given time, the quiet balance is restored, and the system resumes its steady function. Another condition that may arise is the presence of leakage, either of steam or of oil. This is often detected through observation, a faint trace of oil where it should not be, or a slight escape of steam at a joint or fitting. These signs are not dramatic, yet they are meaningful. The railwayman notes them, and when the opportunity allows, the joint is tightened, the seal restored, and the system returned to its proper condition. It is always the small attentions that prevent greater difficulties. In some instances, the locomotive may exhibit a more noticeable change in behavior. A reduction in power, a slight hesitation in motion, or an uneven response to the regulator. Even here, the approach remains the same. There is no sudden reaction, no hurried attempt to correct. Instead, the railwayman considers the possibilities, observing the machine as it continues to work, allowing the cause to reveal itself. It may be that lubrication is insufficient in a particular area, or that a valve is not seating as it should. Whatever the cause, it is approached with patience and care. Even when a defect is confirmed, the remedy is applied with the same calm attention. Parts may be adjusted, lubrication increased, or in some cases, a component may be disconnected or secured in a neutral position to allow the locomotive to continue its journey safely. There is always a method, always a way forward, provided the situation is understood clearly. And understanding comes not from haste, but from quiet observation. It is also important to recognize that not all faults are immediate in their effect. Some develop slowly over time, the result of gradual wear or subtle imbalance. These are often the easiest to manage, for they provide early signs, small changes that can be noted and addressed before they grow into larger concerns. The railwayman, familiar with his engine, is able to recognize these changes almost instinctively. A slight difference in sound, a change in the feel of the controls, or the behavior of the machine under load. These are all part of a quiet conversation between man and machine. And so, as we sit in the calm of the shed, listening to the soft echoes of movement and the distant sigh of steam, we begin to understand that troubleshooting is not a process of urgency, but one of patience. It is not about reacting, but about observing. Not about forcing solutions, but about restoring balance. Each fault, no matter how small, is approached with care, considered in its proper context, and resolved in a way that maintains the quiet harmony of the locomotive. There is no drama in this work, no sudden moments of alarm. Only the steady application of knowledge, the calm use of experience, and the quiet confidence that comes from understanding. And so, as the railwayman continues his reading, and the soft light of the lamp falls once more upon the page, we are reminded that even when things do not proceed exactly as expected, there is always a way forward, a way that is calm, measured, and steady. A way that preserves not only the machine, but the quiet rhythm in which it works. The page turns gently, and the calm, unhurried work continues. A closing, reflective summary. And so, as the final pages of this quiet reading begin to settle, we find ourselves no longer focused on any single part of the locomotive, but on the whole, and on the gentle harmony that exists between all of its parts. What we have followed is not simply a collection of mechanisms, nor a series of instructions, but a way of working that is steady, thoughtful, and unhurried. From the first careful application of oil to the quiet movement of lubricators and the unseen turning of axle boxes beneath great weight, each part has played its role without urgency and without noise. And yet together they allow something far greater to take place. The smooth motion of a locomotive, the steady turning of wheels along the rails, and the quiet assurance that everything is working as it should. It is easy, perhaps, to overlook such things, to see only the movement of the engine or the power that it produces, and not the many small and careful actions that make that movement possible. But here, in the stillness of the shed, with the work laid out calmly before us, we begin to see things differently. We notice the importance of small details, the quiet value of a single drop of oil, placed carefully and without haste, the gentle rhythm of a system that does not demand attention but quietly performs its task again and again, and the steady presence of knowledge passed from one hand to another, not in hurried instruction, but in calm and thoughtful practice. There is something reassuring in this, a sense that even the most complex of machines depends not on force or speed, but on balance, care, and quiet attention. And perhaps as you listen, you may notice a similar stillness settling around you. There is no need to follow each detail now, no need to remember each method or name. The work has been done, the pages have been turned, and everything has been set gently in its place. The locomotive rests. The tools are quiet. The oil remains where it is needed, unseen but present, holding each surface apart, allowing motion to exist without strain. And in that same quiet way, you may begin to rest as well. There is nothing left to do, nothing that requires your attention, only the slow and steady rhythm of a world that continues calmly, whether you follow it or not. The soft glow of the lamp remains, the air is still, and somewhere in the distance a faint trace of steam drifts into the night. Everything is as it should be, and so, as the railwayman closes his book, not with finality, but with quiet satisfaction, the work of the day comes gently to an end. Not abruptly, but gradually, as all things here tend to do. And if your thoughts have begun to drift, that is perfectly as it should be. You may allow them to continue, softly and without effort. There is no need to return to the beginning, no need to stay with the words. They will continue on their own, steady and unchanging, like the quiet systems we have been considering. And so, as the last of the warmth settles into stillness, and the gentle rhythm continues without demand, you may simply rest. And I wish you a pleasant night's sleep.